Okay. Okay, we're recording. Where we left off last time in section 6.2, we were adding and subtracting fractions, but we were doing it with fractions that have like denominators. So just as a real quick review of that, and also this is going to give us a chance to review simplifying. Here is a problem to warm you up today. So we've got negative 3x plus 7 divided by x squared plus 7x plus 12. And to that, we're going to add 8x plus 13 over x squared plus 7x plus 12. So I want you to please add those and then simplify anything you get if it's possible to simplify. All right, when I go to add fractions, what's my process? I have my common denominator. How do I add these? Straight across, right? And then I leave the denominator alone. Okay, so here goes on this problem. I'm going to add my like terms. I've got a negative 3x plus an 8x. That is 5 of them. I've got a 7 plus a 13. That's plus 20. And then we leave the common denominator alone. So x squared plus 7x plus 12. Okay, if you did that, you've done the adding. From here, this is what we talked about in the very first section. Okay, this is just a fraction that needs to be reduced. And the way we reduce fractions is we have to factor. Okay, remember, I made a production of this last time. You cannot just say, oh, hey, 4 goes into 20 and 4 goes into 12, I'm going to reduce. You can't just pick apart terms. It's either the whole thing or none of it. But what I can do is I can factor appropriately. So in the top, how can I factor the top of this? A 5. Yes, we can factor out a 5. And when I do that, 5x, I factor out the 5, leaves me x. 20, I factor out the 5, leaves me plus 4. In the denominator, I've got x squared plus 7x plus 12. The x squared is x and x. This tells me my signs are the same. This tells me they're both going to be positive, so positive and positive. The two factors of 12 that add up to 7 are 3 and 4, or 4 and 3. We do have a common factor. I can now cancel this whole x plus 4 factor, this whole x plus 4 factor, and that leaves me 5 over x plus 3. That's where we left off. Okay, we had added fractions. We had simplified fractions by factoring. Now we get to the new bit for the day. And the new bit for the day today is common denominator day. We're going to use the common denominator to finish up section 6.2. And for what we do in section 6.3, we will also use the common denominator. So we are going to add these two fractions right here. We've got 7 over x plus 4. And we're going to add that to 11 over x minus 5. So the first thing that I have to do is, you notice, unlike the problem I just erased, these denominators are different. So I have to now make a denominator that's the same. Okay, and the way we do that, and the way we did that in arithmetic in middle school when we learned it, is we took factors that were in both denominators and threw them together in a pot, made a stew out of it. Okay, so this is how we're going to find a common denominator. To find the least common denominator. It's really fairly simple process when we have things that are just expressions and it's not messed up with all sorts of numbers. What we're going to do is you look at your denominators and you take one of every factor. You take one of every factor that you see in the denominators. And the only other thing you got to think about then is if there are powers, you take the highest power. Okay, so if there's powers, you always take the highest power. Now that'll happen on our last couple of examples. We're going to focus on this first part of it in our first examples because I know that this working with fractions, adding fractions specifically is probably one of our least favorite things that we get to do. Keeping in mind, just as I've said about canceling, you can't just take one part or the other when things are being added or subtracted. It's either all or nothing. This x and this plus 4, they go together. All right, so my least common denominator of this problem right here. This is step 1 when we're adding our fractions or subtracting. Step 1 is, what's my least common denominator? Well, tell me, I just told you that we take one of every factor we see in the denominators. Give me one of the factors in the denominators. What do you see? Okay, I was hoping you'd say that. X. Now, we can't just take the x. This x right here has a plus 4. Those things are attached. It's all or nothing. This x here has the minus 5. Again, it's all or nothing. These are different denominators, so I can't just take the x. But what I can take is the x plus 4. There's your first factor, the x plus 4. That's the first bit of your common denominator. What other factor do we see? There you go, x minus 5. So it's just observing what my factors are. So I want to reiterate, I can't just take the x because I don't have just a plain old x as one of my denominators. Maybe in both cases, the x is attached to something. So you have to take that other something. All right, so there's my common denominator, step 1. You're going to get your chance to do that a bunch of times. And so we'll sort out any issues as we go. If you have a question, let me know. I know this is a difficult process, and I'm hoping that I can make this as smooth as I possibly can. So then step 2, I have 2 fractions. So what I'm going to do is I'm going to write the common denominator down twice. So for this fraction, I've got x plus 4 times x minus 5, and then plus, and then for this fraction, x plus 4 times x minus 5. If I had a third fraction, I would write down another denominator. What I'm going to try to do here is I'm going to try to show you a process, okay? Something that you can do every time. So you're always doing the same thing every time, okay? Because when you get to do the same thing every time, that's when you can learn it, and then it kind of gets solidified in your brain. Okay, so here's the question now that I have for you. This is what the denominator started out as, just x plus 4. This is my common denominator right here, x plus 4 times x minus 5. What do I have to do to this denominator right here to make it look like this one? Multiply by an x minus 5. Multiply by that missing factor. The reason I'm doing this is if I'm going to change my denominator, there has to be a coordinated change with the numerator. Okay, you can't just do something to one part of the fraction without doing it. So if you are working ahead and you wrote down 7 here, that's wrong. Okay, because we've changed the denominator, there is a corresponding change to the numerator. And the way I figure that out is I note what the difference is. So I multiplied here by x minus 5, so I'll do that to the numerator. I have to do the same thing to the numerator and denominator. So my numerator becomes 7 times x, or 7x, 7 times negative 5, negative 35. So on this first problem, what I would like you to do is I'd like you to make the corresponding change to the second fraction. We give you 30 or 40 seconds to what's different from this, the original denominator, to the common denominator, and use that to figure out what you have to multiply the numerator by. And make your new numerator. What do you have to multiply this denominator by to make it into the common denominator? The x plus 4. So that tells me what I have to do to the numerator. I multiply by the x plus 4. And so my numerator becomes 11 times x, or 11x, 11 times 4, or 44. That's the new part for today. And we're going to repeat this a whole bunch of times. The rest of this we've already done. Now we have the common denominator. Okay, that's a difficult step, and I understand it. So as you're sorting it out and you're working problems, make sure you ask me whatever questions that you have. So I have 7x plus 11x, that's 18x. I have negative 35 plus 44, I think that's plus 9. In the denominator, don't bother multiplying those back together. That's just extra work that does not need to be done. You might be noticing, hey, we can factor a 9 out of the top, and indeed you can, but I notice when I factor a 9 out of this term, I have a 2x. I don't have anything with a 2x here, so nothing's going to cancel. I'm not going to do the extra work. That's done. If you did factor out the 9, great. You have 9 times 2x plus 1 on the top, and you can leave it like that. It's perfectly okay. I'm going to leave that up here. I'm going to write a problem that is super similar to this on the board for you to do. Okay, step 1, find your common denominator. Step 2, write that common denominator down for each fraction. Step 3, change your numerators. And then you can add or subtract, whatever the case may be. So here's a problem for you. Try this. In fact, let's do this in phases, just to make sure we're all working in the same direction. You got a question?
So you say you don't have to simplify that?
Well, if we could simplify, we would, but this doesn't simplify. I could factor out the 9 if you would like to. I can factor out the 9 out of the top, and 18 divided by 9 leaves 2x, and 9 divided by 9 leaves 1. But nothing cancels. So this is not any simpler than this. And that's what I was just saying, is thinking ahead if I factor out the 9. But if you did go through the trouble of factoring out the 9, leave it. Don't go back. Okay, either one of these answers will be the correct answer. They're both reduced fractions. Okay, great question. Thanks for asking. Okay, here's one for you. Try this. 3 over y plus 2 plus 4 over y minus 3. And here's what I would like you to do. I'm going to give you a minute or a minute and a half. I'd like you to identify what the common denominator is. Okay, common denominator. Tell me one of the factors that I need for the common denominator. Okay, I need a y plus 2. Great. Tell me another factor I need for the common denominator. Yeah, and in fact, there's nothing else. Okay, there's no other denominator. So there's your common denominator. So go ahead and finish the problem. Add them together. All right, first fraction. When I compare this to the common denominator, what's missing? Y minus 3. That tells me that I have to multiply the top by y minus 3. So your new numerator on this fraction should be 3 times y or 3y, 3 times negative 3 or negative 9. When I compare this one to the common denominator, what's missing? Okay, the y plus 2, so that tells me I have to multiply the top by y plus 2. So 4 times y is 4y, 4 times 2 is plus 8. That's the new step for the day. That's difficult. We need to talk about that if you're having issues. Beyond that, now I have a common denominator. I'm going to add up. This is the same as the warm-up problem we did before we started this. 3y plus 4y is 7y. Negative 9 plus 8 is negative 1. That does not factor at all, so I have nothing else to do here. There's my answer. There's my reduced fraction answer to the problem. Question? You okay? All right, here's another one. I'm practicing the process. So try this problem right here. Same sort of thing. I've got 5 over x plus 3. And then I want you to add to that 2 over x. Now let's just make sure we're all working in the same direction. What have you written down as the common denominator? What factor? Okay, I need an x plus 3. Sure. And an x. Now this time I can use an x because there it is. Just an x all by itself. Okay, not plus or minus anything. As I go from this denominator to my common denominator, what's missing? What have I added? An x. So my new numerator becomes 5 times x, or 5x. How about from this one? What's different from the original denominator to the common denominator? X plus 3. So in the numerator, 2 times x is 2x. 2 times 3 is 6. So again, now we've done the hard work, the heavy lifting of the problem. The rest is 5x plus 2x. That's 7x. And then I don't have any number over here, so I've just got plus 6. Nothing factors out of that, so we are good to go. There's my answer, 7x plus 6 over x times x plus 3. Anything I need to clear up? Any questions after we've done 3 of these? I've got more that we're going to do. All right, that seems pretty mellow today. Here's a problem that's going to be subtraction. So we'll talk about what to do with that minus sign when we get there. So try this. We've got 5 over x plus 4 minus 2 over x minus 6. So find the common denominator for me, and then we will talk about what comes next. right, what are we going to use as the common denominator on this problem? I need an x plus 4. That's one of the denominators. And then sure, x minus 6. Is anyone having trouble identifying the common denominator? That's the big challenge. Okay, so here's my little tip to you when you go ahead and do this. You're gonna, on the other problems, we've been multiplying by this 2, whatever the numerator is. But since this is a subtraction, my advice would be to multiply by a negative 2. Okay, so treat that subtraction as a negative when you go to distribute. That way, you make sure you subtract everything. So give it a try, and we'll see how you do. And if you make a mistake, it's okay. There's going to be another one. You can fix it. My first fraction is missing the x minus 6. So I'll multiply the top and the bottom by x minus 6. So that makes 5 times x is 5x. 5 times negative 6 is negative 30. The next fraction is missing the x plus 4. Now there's other ways you can approach the minus sign here. If you've done this before, or if you remember subtracting polynomials from introductory algebra. But what I'm going to do is I'm going to treat this negative as with the 2. So negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. And now I'm just going to collect my like terms. Okay, so that's how I like to deal with the subtraction. That way I don't accidentally leave the negative off something when I combine my like terms. So 5x and negative 2x makes 3x. Negative 30 and negative 8 is negative 38. Once again, nothing's going to cancel out of that, so there's no simplifying I have to do. There's my answer. Here's another subtraction problem, just in case you didn't understand what I was talking about with using that as a negative 2. So here's another opportunity. So try this problem. You have 2x over x plus 4 minus 3x over x minus 7. my common denominator on this problem. I basically, in all these problems so far, I've just needed one of every factor that I've seen. So x plus 4 times x minus 7. We're going to do one more problem of this style, and then I'm going to address the idea that I mentioned earlier. If there's powers on things, we take the highest power. We haven't had any powers on anything just yet. So there's my common denominator. So I'm going to write it once for each fraction. X plus 4 times x minus 7. X plus 4 times x minus 7. Once for each fraction. Now I'm going to change these numerators so that they reflect the change in the denominator. So to get from here to here, I multiply by x minus 7. So 2x times x is 2x squared. 2x times negative 7 is negative 14x. To get from here to here, I multiply by x plus 4. Once again, I'm subtracting, so I'm going to treat that as a negative. So a negative 3x. So negative 3x times x is negative 3x squared. And then a negative 3x times 4 is negative 12x. I'm going to collect the like terms. If anything will factor and cancel, then I'll do that. We always want to reduce our fraction. So 2x squared minus 3x squared is negative x squared. Negative 14x and negative 12x is negative 26x. You might notice that there's an x in common. You might have realized, okay, nothing's going to cancel even if I take the x out. So you can leave the answer like that. But if you did notice the x was in common and you factored it out, then when you start off with two x's, you take one of them out, you're left with 1. When you have negative 26x and you take the x out, you just have negative 26. And so if you took it out, then that's fine. Honor the work. Either one of those answers is correct. And so if you factored it, great. You just did an extra step. Didn't help reduce anything, but that's not a big deal. All right, here's another fun problem. Let's say we have this 4 over x squared minus 2x minus 3. And we're going to add to that 3 over x squared minus 5x plus 6. I'll give you a moment to write that down, and then I'm going to give you your first project with regard to this problem. Okay, so project number 1 is this. If I'm going to figure out the common denominator, if I'm going to string together the factors that make a common denominator, I need to know what the factors of these are. So the first thing you need to do anytime it happens, it hasn't happened yet until this problem, you need to factor each of these two denominators. So that's step 1. So I'm going to give you a minute or two, factor each of these trinomials to see what they are. And then once you've done that, hypothesize what you think the common denominator is going to be. Okay, what factors are necessary to create a common denominator? Okay, so factoring each of these denominators. I'm just going to write my factors right underneath here. So x squared minus 2x minus 3, my x squared is x and x. The negative on the 3 tells me my signs are different. The factors of 3, in fact, they're the only factors of 3, so are 3 and 1, and I'm going to make the 3 negative because I need a negative 2. Over here, x squared is x and x. The positive 6 tells me the signs are going to be the same. This tells me they're both going to be negative. And then the 2 factors of 6 that are going to add up to 5 are 3 and 2, or 2 and 3. The order doesn't matter. So there's my factoring. Now I know what factors compose each of these denominators. So now I can figure out the common denominator. So it's proposed to me, what do you think I should have in my common denominator? Okay, I need x minus 3. Great. Anything else? I need x plus 1. Sure. Anything else? X minus 2. Yeah, I need one of everything. Any factor you see, you throw it in the common denominator. Common question. My class yesterday asked me, hey, there's an x minus 3 here. There's an x minus 3 here. Do I need 2 of them? Do I need an x minus 3 squared? The answer is no. You only need the highest power. There's 1 here. There's 1 here, so you only need 1 in the common denominator. Okay, so you're not multiplying to get the common denominator. All right, now that you have that, finish the problem. It works just like every other problem we've done today now. No difference. All right, my first fraction. My first fraction is missing the x minus 2. So I'm going to multiply the bottom by x minus 2 and also the top by x minus 2. So that makes my numerator 4 times x is 4x. 4 times negative 2 is negative 8. The second denominator is now missing the x plus 1. That's what's the new part for the second denominator. So I multiply the numerator by x plus 1 as well. 3 times x is 3x. 3 times 1 is plus 3. 4x plus 3x, that turns out to be 7x. So that's my first term in the numerator. Negative 8 plus 3 is negative 5. That's the second. Nothing factors out, so I know that I'm just about done with the problem after I finish writing down my denominator. There it is. We've taken 2 fractions, we've smushed them together into 1 fraction. When you take college algebra, it's going to have benefit for you because it's easier to consider just the 1 fraction rather than the 2. So that's the purpose of learning how to do this and using this tool. Okay, so we're almost done with this section. I've got 1 more problem I'm going to do, and you have 2 more problems you're going to do. So here's the problem for me. Let's say that we have this 2 over 3x squared, and then plus 7 over 4x cubed. And we're going to add this. Yes. Oh, sorry. What's up?
Will it matter on the test for what we write the denominator for order?
You mean like, did you have the x plus 1 somewhere else? Yeah, it does not matter. You can multiply things. So you can multiply things any order. So if you have like 2 times 3 times 5, it's the same thing as 5 times 3 times 2. Order and multiplication doesn't matter. So that's just a long answer to doesn't matter. Any other questions? Yeah.
What would happen if you have more than two x negative 2? What would happen if you also have x negative 2 and x negative 2?
Like this denominator was missing both of them, and well, then you have a little more multiplying to do. So you would have, so what the question is, in case you didn't hear it, is let's pretend this denominator here was just x plus 1, the way it was given. So my common denominator would still be x plus 1 and x minus 3, x minus 2. I'd still need all three factors. But now this one is missing two things instead of just one. So I would have to multiply this one by the x minus 3 and the x minus 2. In that situation, great question, what you would do is you'd have to FOIL these together first. Okay, so first outers, inners, lasts, then multiply by the 4, and then you'd have a trinomial on top to add your like terms. Okay, so just a little bit more multiplying, but it's the same sort of thing. Great question. Any other questions? That's lovely. Okay, so here, notice the difference on this problem. Instead of having binomials that I have as my factors, I just got two monomials right here. I've got things being multiplied together. So when I have things being multiplied together, we can consider them separately. So when I go to find the least common denominator, what I'm going to do first is I'm going to look at the coefficients, and then I'm going to go back and I'm going to look at the variables. Now the coefficients, 3 and 4. What's the common multiple between 3 and 4? Anybody know? 12. Now in this case, since they don't share any factors, you can just multiply 3 times 4. You can use any common denominator, but using the lowest one tends to make life a little easier. If you don't have a way to find a common multiple, okay, if you don't remember the mathematical way, here is a nice way that's quick and easy, and it'll work for almost every problem you do in this class. Okay, it's called the listing method. I think I mentioned this like on the first day of class when we were talking about solving equations. Okay, so you've already told me the correct answer, but just in case the numbers were a little bit less simple, what you do for the listing method is you take each number that you're trying to find the common denominator or the common multiple of, and you just list multiples until you find the first one they share. And what I mean by that is you start with 3, go 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. And you can always add more to the end of the list, okay? That's the nice thing about this. Then you do the same thing for 4, and now all you're doing is you're looking for where's the first one that matches. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Oh, there it is, just like you already told me. 12 is the common multiple. Okay, so the listing method is nice and clean, and it'll get you the common denominator pretty quickly. The only time the listing method gets messy is if you have very large numbers and you're going to have to write out lots and lots of multiples, but I don't plan to do that to you, so this should be just fine for you. So I need a 12. Then I have a factor of x. I've got x's here, I've got x's here, so I need an x. What did I tell you way back at the beginning when you were still awake about powers when I'm finding my common denominator? The highest. You take the biggest power. So I have 2 x's here, I have 3 x's here, so my common denominator is going to have 3 x's, highest power. From here, my procedure is the same as we've been doing. So I'm going to take my 12x to the third, I'm going to put it once for each fraction. What do I have to multiply this denominator by, the 3x squared? What do I have to multiply that by to make it into 12x cubed? A 4 and an x. 4 times 3 is 12. X times x squared is x cubed. So that means the top, I multiply by 4x. And I get 8x as the numerator of my first fraction. What do I have to multiply this denominator, this 4x cubed, by in order to make it 12x cubed? Just the 3. I don't need an x on this one because I've already got the 3 x's here, so I still have 3 x's. So the x is unnecessary on this one. So I'm just going to multiply by 3. 7 times 3 is 21. And now I'm going to add my numerators. The nice thing that takes even less work out of this is these are not like terms, so there's no actual addition. I'm just going to now make my numerator 8x plus 21, all that over 12x cubed. And we're done. Nothing factors out of the top, so I can't reduce this at all. Here's one for you, very similar. Add these two things for me, please. Let's say we have 9 over 5x squared and minus 7 over 6x to the 4th. So the question, in case you're curious, is why on this one did I multiply by just 3 and no x? So go back to the common denominator. I had 2 x's here, I had 3 x's here. And so we always take the highest power. So we took x cubed. So my common denominator is 12x cubed. Well, I already have 3 x's here. If I multiply by another x, x times x to the 3rd would be how many? X to the 4th. So you've added in an extra 1. That's why. On this problem right here, I'm not going to do the whole thing just yet, but let's just make sure we're all in agreement here. So let's do coefficient first. What's the common multiple between 5 and 6? 30. Okay, you can do that by listing. In this case, again, they don't share a factor, so it's also just 5 times 6 is 30. And then how many x's do I need in my common denominator? Indeed. Okay, so go ahead and keep working the problem if you were still working. If you're done, I'll be with you in just a minute. All right, you told me 30x to the 4th. That was 100% correct. So what do I have to multiply the 5x squared by in order to make it into 30x to the 4th? 6x squared. 6 times 5 is 30. X squared and x squared, the 2 plus 2 is 4. So we'll multiply the top here by 6x squared. 9 times 6 is 54x squared. The second fraction starts off as 6x to the 4th. What do I multiply it by to make 30x to the 4th? Again, just like last problem, no x is necessary because we have 4, so we don't need any more x's. 7 times 5 is 35. And nothing's going to factor out between these two terms, so my answer is just going to be 54x squared minus 35 all over 30x to the 4th. Yes?
You said we were doing the subtraction.
So yeah, so -7 times 5 would be -35. Yeah, still works. The reason I didn't mention it on this one is because I just had the single term. I didn't have to distribute on this one. So there was going to be no cause for alarm. But thanks for pointing that out just in case anybody else was wondering about the inconsistency. All right, one more problem from this section. So if you've got any questions about adding or subtracting, now is the time to get them out of your system. Make sure that we leave here feeling fairly decent about this. I know this is a difficult thing. All right, last problem. We've got 5 over 12x to the 5th, y to the 2nd. So the only difference on this problem is instead of having one variable, there's going to be 2, but that just doubles the fun. minus 3 over 8x to the 4th, y to the 3rd. So I'm going to give you a minute or a minute and a half to please identify what the common denominator is going to be. Okay, least common denominator. Let's start with the coefficients. What's the common multiple between 12 and 8? 24. Okay, so in this case, it's better to do the listing method. 8 times 12 is going to give you 96, and now you're making a number larger than you need to, and it's going to lead to extra work. I need factor of x. How many x's do I need for my common denominator? 5, always the highest power, sure. And I need a factor of y. How many y's do I need for my common denominator? Always the highest power, great. So 24, x to the 5th, y to the 3rd. Finish up this problem, please. All right, so for my first denominator, what do I multiply this by to make it into 24, x to the 5th, y to the 3rd? I'm going to agree with you on the x. The 4 is going to be too much because 4 times 12 is going to be 48, not 24. Oh, in fact, I shouldn't agree with you on the x. That's even better. 2 times 12 is 24. I've already got enough x's, so I don't need any more x's. And then I had y to the 2nd times y gives me y 3rd. I needed one more y. So 2y times 5 is 10y. What do we have to multiply over here by? 8x to the 4th, y to the 3rd to make it into this right here. Okay, I need a 3 and an x. 8 times 3 is 24. I had 4 x's. I needed one more to make x to the 5th. I already have 3 y's, so I don't need any more y's on that. So I multiply the top by 3x. 3 times 3, or negative 3 times 3 is going to be, I got my negative 9x. Again, nothing's going to factor out of the top. That's always lovely to see. It means less work to do. So I have 10y minus 9x, all that over 24x to the 5th, y to the 3rd, and we're done. There's nothing else that I can possibly do with that problem. All right, that's the first thing we're going to do today with the common denominator. So woohoo, we made it.